Good morning, my intermediate macroeconomic students at ECO 3315. Remember, yesterday was our last day of class, but because we missed the class on April 8th because of that solar eclipse, that kind of put us a little bit behind because I'm always on point, finishing just on the dot. So that's why I'm going to be recording this lecture. So make sure this lecture is going to be part of your final exam next week. Make sure you watch the video. I'll send you the link and the password. Watch the video and take your notes. And, I'm going to be engaging you the same way I normally engage you in the classroom on the board, because I have my digital pen. I'm going to be writing on the computer screen. But I got to caution you, though, my writing on the computer screen is not pretty. It might look a little bit like chicken feet, but I would hope you would understand most of the stuff that I'm going to be writing in there. Before I start chapter 12, which is a chapter that we were supposed to finish, I just want to continue a little bit with our discussion of the question and answers, the handout that I gave you guys. I handed on practice question and answers 11, because there was one thing that we did not finish. So I want to share my screen here, and then we'll talk about it on the other side. Here was this is where we ended yesterday. We derived the equation for the IS curve, and we plotted the IS curve. So we found the IS curve is y equals to 1700 minus 100 R. And then we also derived the equation. Remember, the IS curve comes from the goods market equilibrium. So when I ask you to derive the equation that represent the IS curve, you just need to invoke the goods and services market equilibrium. That is real GDP Y must equal to C plus I plus G, because this is a closed economy ISLM framework. Then you need to substitute the consumption function, which is going to be an explicit function given in the problem. You need to substitute the investment function, and then the exogenous policy variables, fiscal policy variables, government spending and tax policies are going to be given in the problem as numbers. And then what you're going to do, you're going to come up with an equation that links Y and R, because the IS curve is a plot of combinations of real interest rate R and real GDP Y when the goods and services market reach equilibrium. So we did that already yesterday before we ended the class. And then we also, whatever we're working on also asks you to derive the equation that represent the LM curve. So the LM curve comes from the money market equilibrium. The LM curve plots combinations of real interest rates and real GDP when the money market is in equilibrium. So the money market reaches equilibrium when real money demand you're seeing there must equal to real money supply. MD over P must equal to MS over P. So most of the time when I'm asking you to derive the formula for the IS curve, I would give you the money supply. And then in this problem, the money supply was given as 1,000, and I gave you the price level, which is what 2. Then I gave you the money demand function. The money demand function was given as MD over P was Y equals to 100. You just go back on the problem. You go back to the problem up here. This is where the money question 2, you can see that the money demand function is what MD over P is given as Y minus 100. So what we did yesterday, if I ask you to derive then the LM curve, all you gotta do is just invoke the money market equilibrium condition that MD over P must equal to MS over P, then substitute for the non-values. Substitute the money demand function, which is Y minus 100 R, must equal to the M, which is 1,000 divided by 2. So you come out with this simple equation, Y equals to 500 plus 100 R, okay? So now we have, since we have the 2 equations, we also talked about, equilibrium, short-run equilibrium, okay? So short-run equilibrium in this Keynesian framework is going to be a situation whereby there's simultaneous equilibrium in the money market and the goods market. So when the money market and the goods market reach equilibrium at the same time, we say that we're in equilibrium, okay? We're in some kind of short-run equilibrium. So I'm gonna open up a small empty slide here to kind of try to show you how you would solve for that short-run equilibrium. So just as our graph depicts, the way we derive things here. So if this is my graph, I'm going to draw here. Okay. So we always put interest rate on this axis, real interest rate, and then real GDP on this axis. So the LM curve, which we just derived, is upward sloping, right? So the LM, the equation for the LM, we found it to be Y equals to, I believe it was 500 plus 100 R. That's what we found there. This is your LM. Okay, which by the way, or you could rewrite this one here, make R a subject. You can do it differently. You can, but if you take 500 to the other side, you can find that your R is going to be equals to -5, okay, plus 0.01 Y. Okay, if you make R the subject by take 500 outside, you can also write it in this way. So, and then we also derived the equation that depict the what? The IS curve. The IS curve slopes downwards, remember? So we can label this IS. And our equation that we derived there was Y was equal to 1700 minus 100 R. See, there's a negative coefficient on R, it's showing that because the IS curve has a negative slope. Or you could make R the subject, okay? If you make R the subject, take 1700 outside, then divide all through by 100, you're gonna get R equals to 17 minus 0.01 Y. So you can either write the IS equation this way or this way. You make R the subject. So now the most important thing that we gotta do here, the next question on which we did not finish, asks us to solve for short-run equilibrium. Okay, we're solving for short-run equilibrium values of interest rate and real GDPY. So that point of equilibrium is so when the money market, which is depicted by the LM curve, and the goods and services market, which is depicted by the IS curve, when both of those markets reach equilibrium simultaneously, then the point that the LM curve and the IS curve will have to intersect. So the point of intersection is what we are calling short-run equilibrium output, determines your short-run equilibrium output. Remember, this is a Keynesian model, so this is Y, and then determines short-run equilibrium interest rate. Okay, so now since we already know the equation for the LM curve is basically this equation here, or this, and we know the equation for the IS. So these are two at the point of intersection. If you want to solve for R and Y, it's very easy. You have to solve for R and Y simultaneously. It's a simultaneous equation system, because at the point of equilibrium, there's only one interest rate. There's only one output. So, so what we got to do here is basically, I'll open a new slide here. We just say, since we know that, that Y equals to, the LM curve is giving us 500 plus 100 R, and the IS curve is giving us 1700 minus 100 R. What we need to do is, all you got to do is just set the right-hand sides equal. Set the right-hand side of these two equations, because this is your LM equation, this is your IS equation. So you got to just set the right-hand sides equal. If I set the right-hand sides equal, I'm going to have 500 plus 100 R must equal to the right-hand side of the IS equation, which is 1700 minus 100 R. Okay, now all I got to do is just collect like terms. I can bring 100 R to the left, then take 500 to the other side. If I bring 100 R to the left, that means I'm adding both sides. The left-hand side is going to be 200 R must equal, then I subtract 500 from both sides. That means I subtract 500 from here, then subtract it from here. These are the right-hand side will remain with 1200. Now to solve for R, I'm just going to divide both sides by 200, divide by 200. So these cancel, see? So that means the short-run equilibrium interest rate is 6%. Okay, now to solve for your short-run equilibrium output, you are going to substitute this 6% either in the LM equation or in the IS equation. Either way, you're going to get the same answer. Trust me. So that means short-run equilibrium output. If we pick the LM curve, that's going to be Y equals to 500 plus 100 times 6. 100 times 6 is 600. 600 plus 500. So this is going to be 1100. Okay, so now we have solved for those two equilibrium. Okay, so we can go and basically, again, we can plot it if you want it, but you don't really need to. But again, if you go back, so this is what we have solved for. This is your LM curve. Then this is your IS curve. Okay, so we have solved for this short-run equilibrium values of output, okay, which we found to be 1100, and we have solved for this interest rate, which we found to be 6%. Okay, that's how you solve. So anytime I ask you a question on this topic, to solve for short-run equilibrium values of interest rate and real GDP Y in the IS-LM framework, you just need to solve the IS equation and the LM equation simultaneously, which is basically setting the right-hand sides of those two equations equal. Okay, so it's like we have just done it here. And then there are a couple of questions. So let me go back to that handout again, the Q&A. So there are a couple of questions that I asked you there as well. So let me go back here and reshare the screen. Hope I still have it. Should be this one. Yes. Okay. So now, so this is how we have solved for these points. So you can see we have found this to be 1106 there. Now I asked you a couple of questions now, which are basically just they are basically, I say, suppose, for example, the government spending has been raised from 100 to 150. Okay, how much does the IS curve shift? What are the new equilibrium interest rate and real level of income? So you remember, government spending G enters the goods market equilibrium. When you invoke the goods market equilibrium, that's where we derive the IS. So once the government spending has changed from 100 to 150, you need to go. That means the IS curve. We talked about it on Monday. On Wednesday last week. This is an expansionary fiscal policy. When G goes up, the IS curve is going to shift to the right. So that means that all IS is no longer going to be relevant. So theoretically, you're going to be shifting the IS curve to the right. I think I put it here. See that? Shifts to the right. So that means we need to go and derive a new equation for the new IS curve using the new government spending 150. So you go back and derive the new IS equation. You just go, which is basically Y equals to C plus I plus G. Everything else is going to stay the same except G has gone up to 150. You get a new equation. And if you do that, you're going to find that the new IS equation is going to be Y equals to 1900 minus 100R. So you can see clearly, because you can see that the intercept of the IS curve has changed by 200, because it was 700 here, but now it's a jump to 1900 because the IS curve has shifted to the right. So now, to solve for the new equilibrium, if I ever ask you to solve for the new equilibrium, so the new equilibrium must jump from the old equilibrium where you had 6 and 1100. Sorry, those terminal points are not drawn accurately. They're not matching. But you can clearly see that the new equilibrium is going to be where if you solve for the new equilibrium, you're going to see that interest rate is going to jump to 7%. And equilibrium, short-run equilibrium is going to increase to 1200 because we have shifted the IS curve to the right. Then there's another question. I say it's part G. I say, suppose instead that the money supply is the one that is being raised. Suppose the Fed conducts an expansionary monetary policy. The expansionary monetary policy is basically increasing the money supply, which typically leads to lower interest rates. So in this case, the Fed has conducted a monetary expansion from 1,000 to 1,200. So, but we know that, when you're talking about money market, that's where we derive the LM curve. So anytime the Federal Reserve has changed the money supply, you need to go back to the LM equation, so to your money market equilibrium, and rederive a new LM equation with a new money supply. Like we're doing, you're seeing that on the slide. So M over P now is going to be 1,200 over 2 equals to 600. Then we're going to set that equal to the money demand. Money demand is still Y minus 100 R given in a problem. So 100 minus Y minus 100 R equals to M over P, which is 600. So your new LM equation is going to be Y equals to 600 plus 100 R. So you can see clearly the original LM curve was Y was equal to 500 plus 100 R. So it's the intercept of the LM curve that's jumped by what? By 100. Okay, which is just jumped by the size of the what? Almost by the size of the monetary expansion, but not quite. It just increased by 100. Okay, so this is how the LM curve is going to shift to the right because of that because of that monetary expansion by the Fed. Now, if I ask you to solve for the new equilibrium interest rate, you're going to put this in equilibrium context. You draw your IS curve. So let's assume that we're assuming the original IS curve before government changed spending, which was Y equals to 1700 minus what? Minus 100R. So we're now drawing that, we know that the oil equilibrium allowed us to get interest rate 6 and 1100. But now if the LM curve shifts to the right, you can see that that's going to lead to a lower interest rate. And if you go and solve the new LM curve simultaneously with the old IS curve, you're going to find that the new interest rate is going to fall to 5.5% from 6%. And the new output level, GDP, is going to increase from 1100 to 1200. Okay? So that's basically what I wanted to talk about on that. Now, I'm going to jump and go to start talking about chapter 12, which is basically the extension of the IS-LM framework. Okay, so let me share my screen again, and we talk about it on the other side. Okay, so this is the aggregate demand to applying the IS-LM. So now that you know what the IS-LM is about, let's go to the actual application of it. Let's go and apply it. Okay. Okay, so here's going to be the context of this chapter. Chapter 10, introduce a model of aggregate demand and aggregate supply. Chapter 11, develop the IS-LM model, which is a basis for aggregate demand curve. So in this chapter, we're going to use the IS-LM model to analyze the effects of shocks. Shocks can be fiscal policy shocks, could be monetary shocks. It could be some other exogenous shocks to, say, aggregate demand, like shocks to the consumer sector. Like, for example, when consumer confidence goes up or goes down, U.S. consumer confidence always changes over time. That is going to be an exogenous shock to aggregate demand. Or shocks could be business confidence could change. Okay. So we're going to talk about that. And then we're going to use I'm going to show you, as I told you the other day, if you go somewhere, you're lucky enough to go to the graduate school, nobody teaches you aggregate demand, aggregate supply model anymore because it's too simplistic. We end at this level, at the undergraduate level. So if you're lucky, they may talk a little bit about the IS-LM framework. So what we're going to do is that you're going to find that the aggregate demand, aggregate supply framework is a watered down version of the IS-LM model. So in this chapter, I'm going to enable you to recover your aggregate demand function from the IS-LM framework. I'm going to show you how to derive it. Then we can skip the theories of the Great Depression. Okay. Okay, so here's what we talked about. Okay, we said that simultaneous equilibrium in the money market and the goods market result into short-run equilibrium interest rate and short-run equilibrium output, which is depicted in this red. See that? So that means when the goods market, which derives the IS curve, and the money market, which gets you the LM curve, when those two markets reach equilibrium simultaneously, that means the IS curve and the LM curve will intersect. And the point of intersection depicts short-run equilibrium point. When that will determine your corresponding terminal short-run equilibrium values of interest rate, R1 there, and short-run equilibrium output level. Okay. Remember, this is the money market reaching equilibrium. The right-hand side is your aggregate demand. So it's the money demand. Remember the money demand function, M over P, D, in general, is a function of what? Real interest rate and Y. And then so we're saying that the money market reaches equilibrium when the real money supply, which is on the left-hand side, must equal the real money demand. But real money demand is a function of what? Real interest rate and real GDP. So let me reiterate this again. The intersection between the IS and the LM curve determines short-run equilibrium values of real GDP and real interest rates. Okay, so what we're going to do the first thing we're going to start doing the policy analysis. So in the previous chapter 2, chapter 11, I showed you guys that fiscal policy shocks, like changing government spending or changing tax policy, will shift the IS curve. And then monetary policy, which is controlled by the Federal Reserve, or will what? Changes in monetary policy, changing the money supply and interest rate, will shift the LM curve, left or right. For example, if the Federal Reserve decides to increase the money supply, the IS curve is not going to shift. The curve that is going to shift is going to be the LM. The LM curve is going to shift to the right. Or if Congress decides to increase government spending, you know that is the IS curve that is going to shift to the right. You know, expansionary fiscal policy involves either increasing government spending or decreasing taxes, because those are those tools of fiscal policy are controlled by the U.S. Congress at the federal government level. You know that the executive branch proposes the budget. That budget must be approved by Congress. Okay, federal spending or federal taxes must be approved by Congress. So you could in other words, you could say maybe Congress can affect the shape of the IS curve, while the Federal Reserve can affect the shape of the LM curve using monetary policy. So let's discuss a few of those changes. For example, if there's an increase in government purchases, say Congress decides to expand the size of the budget, meaning that they increase government spending. See, so you can see clearly the IS curve is going to shift to the right. Okay, so think about this for a second, though. This is going to lead to a higher interest rate, and GDP is going to go up. But the way GDP is going to go up, GDP is going to increase by more than the size of the government spending increase. We talked about that in chapter 11 too, because of the multiplier effect. Remember, if the government increases spending by $1, that every $1 is going to multiply itself a certain number of times to generate a change in the level of real GDP. It could be 4 times. Like for every $1 spending by government, the spending increase by U.S. government can increase GDP by $4 more. Okay, so this is going to be how much your output is going to change. Remember 1 over 1 my fiscal multiplier, this government spending multiplier is given by what? Again, let me remind you if you did not if you forget for some reason. So here's what we say. We say that spending multiplier, or you can say government purchases or government spending multiplier. So we derive the formula for the multiplier. We say change in Y divided by change in G is given as 1 over 1 minus MPC. Okay, so if I cross multiply both sides by change in G, right? So this cancels. See, that means output is going to change by 1 over 1 minus MPC times delta G. So if we know the size of MPC, let's say MPC is 0.75, and the government spending increased by $50 billion, for example. So that means GDP is going to change by what? Change in GDP is going to be equal to 1 over 1 minus 0.75 times $50 billion. Okay? But you know, 1 over 1 minus 0.75 is what? That's going to be 4. So you multiply 4 times $50 billion, which is just going to be $200 billion. So you can see GDP is going to increase by 4 times as much, because in this case, every dollar increase in spending raises GDP by $4. So that means if you spend $50 billion, that $50 billion is going to raise GDP by $200 billion. Okay, so that's why you're seeing that the shift, this change in output from Y1 to Y2 is going to be a lot higher than the change in the spending. Okay, so but theoretically, if you shift the IS curve to the right due to an increase in government spending, you can see that the new equilibrium is going to be at this point. Okay, where the way the new IS curve, IS2, the red line intersect the black line, which is the LM curve. So equilibrium real interest rate is going to increase, and equilibrium output is going to increase. So up to this point, you need to know factors that shift the IS curve, because the factors that shift the IS curve are completely different from the factors that shift the LM curve. Once you master that, then this model actually becomes very, very, very easy. For example, if the government gives a tax cut, remember, expansionary fiscal policy by Congress, if you want to increase GDP, you either increase government spending, which we talked about it here, or you could cut taxes. If you cut taxes, the IS curve is going to shift to the right as well. The decrease in taxes means consumers are going to spend more money. It stimulates consumer spending. So that's going to shift the IS curve to the right. So it has got similar in terms of the direction of movement on interest rates. The equilibrium interest rate is going to rise to R2, and GDP is going to rise to Y2. The only difference is that because I showed you in chapter 11 that the tax cut, which is given by minus MPC or 1 minus MPC, is smaller than the government spending multiplier in absolute terms. So, for example, if the government want to increase GDP by spending $50 billion, the impact of that $50 billion on GDP is going to be a lot greater than if the government decided to give a tax cut of $50 billion. Okay, GDP is still going to increase when you give a tax cut, but not as much as it would if you increase spending instead. Because there are two ways that Congress can stimulate the economy. Either they collect all the tax revenue and then they raise government spending, or they can keep government spending constant and give a tax cut. Okay, those are two ways that fiscal authority, the Congress, can stimulate the economy. But all what I'm saying is that, as we said in chapter 11, taxes have less, because this is a static model, will have less stimulative power compared to government spending in terms of how much GDP goes up. Okay, what about monetary policy? What about if the Fed, because if we're not stimulating the economy using fiscal policy, we could stimulate the economy using monetary policy. So here the role for the Federal Reserve. If the Fed increases the money supply, we talked about that the LM curve is going to shift to the right. So you can see if the LM curve shifts to the right, that's going to lead to a decrease in interest rate and an increase in what? In output. Okay, so those are clear. And then the converse is true. What about if the Federal Reserve had decreased the money supply? If the Fed had decreased the money supply, then the LM curve would shift to the left instead, like that. See that? So the interest rate will rise for a monetary contraction like that, and real GDP will fall. See that? So a monetary contraction by the Federal Reserve, which involves decreasing the money supply, will shift the LM curve to the left. That will lead to an increase in interest rates and decrease in what? In real GDP. Okay, now I want to talk about something which is even very important here. The interaction between monetary and fiscal policy. Okay, so fiscal policy and monetary policy sometimes don't work in isolation. I want to give you one example. For example, during tough time, let's say the economy, we go through the financial crisis where the economy is going to a serious recession. Sometimes Congress and the Federal Reserve may be, not that they're working together, but they work like in the same direction to try to jumpstart economic recovery, to make sure that the economy recovers from a recession. So if you are Congress and the economy is in a deep recession, you would want to be spending more government money, what you call monetary expansion, or giving tax cuts. Because the idea is you want to shift the IS curve to the right, or shift the aggregate demand curve to the right to close the recessionary gap. If you're the Federal Reserve, you would be conducting an expansionary monetary policy. You would be increasing the money supply, which leads to a decrease in interest rates. See, but there are also cases sometimes where Congress may do something on fiscal policy, which might end up changing interest rate or GDP, and the Federal Reserve may not like that. Okay, the Fed may want to counteract the impact of what. So this type of policy is what we call. We're gonna call this a policy mix. We're saying we're mixing policy mix, or sometimes we call it policy accommodation by the Fed. Okay, so policy accommodation is with the idea that the Fed may change monetary policy. They may increase or decrease the money supply in response to changes in fiscal policy by Congress. Changes in fiscal policy by Congress. For example, if Congress decided to increase government spending, and the Federal Reserve might think that that might not be a good idea because they don't want interest rate to go up, the Fed may use monetary policy to counteract the impact of that fiscal policy expansion. Okay, so let's talk about how this works out. So they are going to be, so let's say suppose the Fed, suppose Congress decide to increase government spending. The Federal Reserve has got three possible responses to this congressional fiscal expansion. if the Fed thinks that what Congress has done at that point in time was actually good for the economy, they're going to let it go. They're going to do nothing. Doing nothing means the Fed is going to hold money supply constant. That means the Fed actually agrees that at that point that Congress has done something good for the economy. But the other two scenarios, because remember, when the government increases spending, the IS curve is going to shift to the right. I showed you earlier already. That's going to lead to an increase in interest rate and an increase in real GDP. But if the Fed doesn't want interest rate to increase, the Fed is going to use monetary policy to hold interest rate constant. And I'm going to show you on the graph what the Fed will do there. Or sometimes if the Fed, the goal of the Fed was to stabilize output, they don't want output to change, because when Congress increased spending, IS curve shifts to the right, GDP goes up, and the Fed doesn't want the volatility in output. They want to stabilize output at a regional level. Then they're going to use monetary policy. I'm going to show you how they do that. But in each case, the effects of change in government spending will be different. So let's look at the first case. The first case, when Congress decides to raise government spending, increase G, we know that the IS curve shifts to the right. And as I say, that's going to lead to an increase in interest rate. See, the new equilibrium is here. Interest rate is going to rise from R1 to R2, and GDP is going to increase from Y1 to Y2. So in this case, the Fed is holding money supply constant. See, the LM curve does not change, meaning that the Fed does nothing in this case, because the Fed thinks whatever Congress has done, raising government spending, is actually good. Maybe it's about time we need to raise interest rate and increase GDP. So that's case one that I talked about. But the other case is case two. Okay, so when Congress, for example, decide to increase government spending, like we talked about, and the Federal Reserve thinks that because that potential would raise interest rate. The idea is that we would at least be at that point. But if the goal of the Federal Reserve is to hold interest rate constant, they don't want the volatility, interest rate to rise from R1 to R2. The Fed is going to counteract that fiscal expansion, which shifted the IS curve to the right by increasing the money supply. Because when the Fed increases the money supply, the LM curve is going to shift to the right. So as you can see that the point where the new LM curve 2 intersect with the new IS curve 2, we hold interest rate at its original level of R1. But that is going to increase output even further to Y3. So in this case, at this point, the Fed would not, the goal of the Fed would not be stabilizing output, but there would be they want to stabilize maybe interest rate. They want interest rate to be constant. So let me say that again. Suppose Congress decides to increase government spending, that would shift the IS curve to the right. That would potentially reach this point, where interest rate will rise and GDP will rise to Y2. But if the Fed thinks that they don't want interest rate to go up from R1 to R2, they want to stabilize our interest rate at R1. They are going to counteract that fiscal expansion by Congress with a monetary expansion by increasing the money supply. So when they increase the money supply, the LM curve is going to shift to the right, and that is going to hold interest rate constant at R1. But real GDP is going to increase further to Y3. So that's a type of policy mix or policy accommodation by the Fed that I'm talking about. Okay. Sometimes Congress might do something which might be in contrast to what the Fed wants. Okay. And then the third case is a case where, following a fiscal expansion by Congress, the Fed may want to keep output constant. So remember, when the IS curve shifts to the right, when Congress increased government spending, potentially we're supposed to be at this point here, where interest rate will go up to R2 and output should go up to Y2. But if the goal of the Federal Reserve is to stabilize output, to hold output constant at a regional level Y1, then the Fed is going to counteract the impact of this fiscal expansion using a monetary contraction. Monetary contraction basically means the Fed would be reducing the money supply. So if you reduce the money supply, we say that the LM curve is going to shift to the left. And it's going to shift. They're going to do it by just enough to ensure that the intersection of the new LM curve and a new IS curve, which happens at this point, will keep output at its original level. But in that case, interest rate is going to rise even further to R3. This is a case where the goal of the Fed at that time is to stabilize output, but not interest rate. They will let interest rate go. Okay. So that is how Congress might respond, sorry, the Federal Reserve may respond to a congressional, actions on fiscal policy, changing spending and tax policies. Okay, so the Fed counteracts it using monetary policy. And you guys, you should be asking yourself, why would be the case? Remember, Congress also made, I'm not trying to be cynical, but Congress is made up with a bunch of politicians. Okay, they're smart, most of them are lawyers. Most of them are not economists. So sometimes they may, in a heated debate between, say, the Republicans and the Democrats, they may pass a bill, okay, which which they may not think through carefully what the ramification of those, those bills might have on the economy. Because for the most part, most congressmen or congress women are not trained economists. They are not, they're lawyers, they're smart lawyers. A lot of them, they may not understand the implication or the ramification of fiscal policy expansion or contraction on output and interest rates. The Federal Reserve is comprised of highly trained technical experts on the economy. So they can read the signal, what Congress is doing. If they feel like what Congress is doing is counterproductive to the economy, okay, they're going to counteract that by using monetary policy to somehow subdue the original, what the initial impact of the fiscal policy would be on the economy. They would subdue that using what? Monetary policy. Okay. All right, so let's continue with our discussion here. So now let's start talking about shocks. In the chapter of aggregate demand, aggregate supply model, we talked about that shocks to the macroeconomy can be some form of demand shocks, or they could be some kind of supply shocks. So we're also going to be talking about shocks to the IS curve, so anything which shifts. So I'm going to talk about it here. Let me open a slide here to kind of share with you what I want to talk about here. So when I talk about IS shocks, right now you all know what shift the IS curve. So anything which shift the IS curve, including fiscal policy, to the left, all right, is an IS shock. And then we're also going to talk about the LM shock. You know the LM shock, anything which shift the LM curve, including monetary policy by the Fed, shift the LM curve to the left or right, is an LM shock. So just like we talked about shocks in the aggregate demand, aggregate supply model. So if the shifting of the IS curve is going to the left, then we call that a negative IS shock. If you're shifting the IS curve to the right, we call it a positive IS shock. Same for the LM curve. If the LM curve is shifting to the right, we interpret that as a positive LM shock. Shifting it to the left means a negative LM shock. Okay, so let's kind of talk about example what an IS shock will look like. Okay. So examples include things like the stock market boom or crash. Think about if the stock market is booming, that means American households become wealthy. That's going to lead to a change and increase in the size of household wealth. Or if the housing market is booming, Americans feel like they're wealthier. And if they're wealthier, that's going to boost consumer spending. So consumer consumption is going to go up. So when consumer spending is going up, that consumer spending is within the what? The context of the aggregate demand, aggregate supply is within the goods market. So that's going to shift the IS curve to the right. Okay. But when the stock market crashes instead of booming, that means American households are losing wealth. They're going to cut spending. When they cut spending, so consumers are going to have low confidence. That's going to shift the IS curve to the left. Okay, there could be other things that can affect consumer confidence. One of them could be like terrorist attacks. For example, in 2001, we had the 9/11. terrorists attacked us here on our own homeland, you know. So that brought a lot of fears in American consumers, American businesses. So terrorist activities can be interpreted as some kind of negative IS shock because consumers are going to reduce consumer spending. Businesses are going to cut back because they're not sure what is coming next. That's what we saw happen immediately after 9/11. Okay. So anything that is going to change consumer expectation, consumer confidence, whether negatively or positively, okay, like terrorist activities, like stock market crashing, those kind of stuff, the economy heading in the wrong direction, or in a good direction, whatever you call it, is going to shift the IS curve. Okay. Or it could even be fiscal policy. Congress increasing or decreasing government spending, or increasing or decreasing taxes. We already discussed this. So anything that will shift that line, that curve, IS curve, is going to be including fiscal policy and whatever I've discussed here, things that could affect consumer confidence and business confidence, will lead to a shift of the IS curve, whether left or to the right, depending on the direction of movement of those variables. What about the LM curve? The LM curve, we talked about it, exogenous changes in demand for money. So the LM curve, anything that shifts the LM curve, including monetary policy itself. But remember, we talked about it, that there could be other factors that can shift the LM curve to the left or to the right without the Fed printing money or decreasing or increasing the money supply. One of them, which we talked about, a wave of credit card fraud, which makes Americans tend to use cash more frequently in transaction, is going to lead to an increase in money demand, shifting the money demand curve to the right and shifting the LM curve to the left. We went through this in class already yesterday. So credit card fraud, like for example, I remember like 6 years ago, Target reported that millions of Americans had their identity compromised at Target. But let's say this becomes a serious problem, that people are hacking on our credit cards and our debit cards. That means most Americans will fear shopping using debit cards and credit cards because they fear their identity being compromised. So most Americans would demand more cash. We want to shop with cash. When I shop with cash, nobody steals your identity. So that means that's going to lead to an increase in money demand. People are going to demand more dollars. And that's what we said yesterday, that identity theft, like credit card fraud, that increases the demand for dollars, is going to lead to it's going to shift the LM curve to the left. So it's like some form of a negative LM shock. And then also more ATMs or the internet to reduce money demand. Back in the days when we did not have ATM, people used to demand a lot of dollars because of the inconvenience it would take somebody going to line up for funds at the bank to withdraw money. But because of the improvement in the payment system, the innovation, like the discovery of the ATM machine and debit cards, you don't have to stack a lot of money at home, because you can leave that money in the bank earning interest. You can just withdraw a little because with less inconvenience, because we have ATM machines everywhere. So perhaps you can argue that inventions such as the introduction of ATM machines and debit cards help to reduce money demand, meaning that the money demand curve shifted to the left. That means the LM curve will shift to the right, because it will lead to lower interest rate. Okay. So we can use the IS-LM model to analyze the effects of a housing market crash, like it happened in 2006, 2007. You remember the housing crash? Or maybe you guys were still in grade school, but the housing market was a meltdown in America, was really bad. What led to the financial crisis of 2007, 2008? Okay, it started from the housing market. So when the housing market crashed in 2006, 2007, most Americans felt like, when their home values got diminished, they felt like they were less wealthy. So consumer confidence went down. So the IS curve shifted to the left. So we can use the IS curve to show what happened in 2007 following the housing meltdown. See, consumer confidence went down because of lower wealth. That shifted the IS curve to the left. See, that lead to a new equilibrium where the new IS curve inside the LM curve, interest rate fell and GDP falls. So that's why we had like a recession, the Great American Recession of 2007, 2009. Okay. We can also analyze the impact of a credit card fraud, which leads to consumers using more money more frequently in transaction. Credit card fraud, as we talked about, it was going to shift the money demand curve to the right, but shifts the LM curve to the left. Okay. So that's going to lead to a decrease in income, real GDP, and an increase in interest rates. So let's talk a little bit of case studies here. Before I start now talking about the aggregate demand function that I told you about to recover the aggregate demand. During 2001, following the terrorist activity, the United States, during the Bush administration, we had a September 9/11 attack on the US soil. It was followed by a recession. So 2.1 million jobs were lost. Unemployment rose from 3.9% to 5.8%. GDP slowed down by 0.8% compared to 3.9% average annual growth during the 1994 to 2000. You see, during the most of the Clinton good days of the 90s. So here's what happened in the stock market following 9/11. Okay, the S&P index was rising until we were hit by terrorists around 2001. See how the stock market literally crashed, the S&P index. And that stock market index led to lower consumer confidence because households are losing wealth. When the stock market crashes, you lose wealth. That leads to decrease in what? Consumer spending. So this is a type of IS shock that I was talking about. Okay. So following that night, the causes of the 2001 recession was, I told you, it was 9/11 terrorist attacks on the US soil, which led to increased uncertainty, fall in consumer and business confidence. Okay? The result was lower spending, so the IS curve shifted to the left. During the same year, too, in 2001, we had some tremendous corporate accounting scandals in America, like the scandal at Enron, WellCome, where companies were cooking books of accounts. When they got caught, that kind of brought a lot of brought the market down in a way, because people lost confidence in the market, because when major US corporations start, misleading investors in terms of basically not doing the accounting right, that's what we saw happen in 2001. That even reduced stock prices further, discouraging investment. And we don't want companies doing stuff like that. So here was the response by when we were hit by terrorist attacks. Here was the response by the government. Congress did things, increase government spending what was needed for New York City reconstruction projects. Okay, the Afghanistan war, that means more spending. We had to go and start looking for the terrorists that will attack us. And then the government also gave tax cuts to keep the economy moving. Remember, after 9/11 terrorist attack, Americans were not flying because people were very scared of flying. Okay, so the airline industry, most of they went bankrupt. So the government had to bail out, like American Airlines, Delta. Some of those airlines received bailout funds from government. Okay, so the idea here is that when the terrorists hit us, that led to low confidence. The stock market was crashing. The IS curve shifted to the left. Then the government responded by raising spending, because the idea, you need to shift the IS curve to the right. Okay. So this is what happened. The Federal Reserve also countered, so we use both monetary policy and fiscal policy to counteract the aftermath of the 9/11 on the economy. So while Congress was raising spending for New York City reconstruction projects, Afghanistan war, and maybe like bailing out, the airline industry, the Federal Reserve was lowering interest rates to keep the economy strong as well. So you can see the monetary policy response. Interest rates are falling on 3-month Treasury bills. They already went down. Okay, that's how the Fed was responding. Okay, I just want to talk briefly about the Fed's policy instrument. So when the Federal Reserve is changing the money supply or decreasing interest rate, which interest rate does the Fed target? The Fed does not target the market interest rate. The Fed targets what we call the federal funds rate. The federal funds rate is this overnight interest rate that banks charge each other when they loan each other funds. So there's a big market out there called a market for reserves, a market where private banks borrow money from each other. So the interest rate they charge each other is what we call the federal funds rate. Even though that is an arrangement between private banks, the Fed actually controls that interest rate, the federal funds rate. because the Fed can control the supply of reserves in the banking system. We saw that earlier on in chapter 4 or 5. Okay. Okay, when we were talking about, the money multiplier, this kind of stuff, the monetary base and the reserves in the banking system. So, for example, if the Fed wants to lower the federal funds rate target, they are going to buy bonds. When they buy bonds, that leads to an increase in reserves in the banking system. So when the supply of reserves goes up in the banking system, then banks, that's going to lead to a decrease in the federal funds rate. Okay. So the Fed changes the money supply and shifts the LN curve to achieve its target. For example, if they want to lower that interest rate by 50 basis points, the federal funds rate, they know precisely how much bond purchase is going to require to lower interest rate by 50 basis points. Okay. Lately, the Fed has been raising that target, the federal funds rate, because of inflation since last summer. We know that the federal funds rate has gone up a lot. There's a reason why the Fed likes to target interest rate, instead of targeting the money supply directly. Because one of the obvious issues is measurability. Interest rates are easier to measure than money supply. And the Fed might believe that the LM shocks are more prevalent than IS shocks. So if so, then targeting interest rate will stabilize income better than targeting the money supply directly. So now let's talk about, remember earlier on when I started this chapter, I made it clear that we can recover the aggregate demand function or curve from the ISLM model. Okay. Remember the ISLM, when the ISLM is intersecting, right? IS is intersecting LM. We say that the economy is producing it. That's short-run output, results in the short-run output and short-run interest rate. Because this is Keynesian model. The Keynesian model is a model of the short-run when prices are sticky. So when, but remember, there's one thing that you gotta know though. I want to do something here. Okay. Even though, so, when we talk about classical model assume that there's only one. So classical model, like the traditional classical model we've been talking about in the class, assumes that there's only one unique output level, which is Y bar. And that Y bar is a function of capital and labor. So this output is what you can call it the long run aggregate supply. We can just call it long run output. When the economy is in long run equilibrium, we said it over and over in this class, that, and that's classical model, they believe that the economy is always producing at full employment. That means changing GDP, as we said earlier on, is only due to three things. Capital buildup, increased labor resources, and maybe it's changes in technology. So the long run aggregate supply curve is perfectly inelastic. Okay, if I call this long run aggregate supply curve 1, you produce this Y bar 1. Okay, so this is your output measured on this axis. So again, then when this thing can increase to what? Like that. We can shift it to the right. And what brings about the increase in the long run aggregate supply curve? When we build more capital, when we get more labor, we invent new technologies. You can shift it to the left. Shifting it to the left could be due to things like natural disaster. Natural disasters that destroy capital, for example, or it can destroy labor. It can affect how much we produce, like the tsunami that happened in Japan, the hurricane that happened in Japan, many years ago, that destroyed capital, that killed several people, Japanese people. That can lead to a reduction in the what, or it could be something of like pandemic, like COVID-19, that killed so many Americans. We reduce the size of labor of the COVID-19 because, COVID-19 killed so many people. That could have a negative impact on what? On this long run aggregate supply curve. So now what I want to talk about is that even though, so when we talk about the Keynesian model, so in the Keynesian model, which we talk about it, Keynes argues that there's no output. There are three case scenarios under the Keynesian model. Keynes agrees that, well, actual output can be equals to what? It's full employment, just like the classicals are telling us. Keynes argues that is true. But sometimes Keynes allows for two other scenarios. That even though actual, so this Y without a bar is your actual output that the economy produces. You can label it actual output. Okay. This is your full employment or long run output. Then two, Keynes might argue that sometimes your actual output could be less than your full employment. The economy could be producing in recessionary gap. Because when actual output is less than below your full employment, that results into a recessionary gap. Or the last scenario is when your actual output could be above, the economy could be overheated, produced beyond its full employment value. That leads into what we call inflationary gap. We know, you know this already, even from chapter 10. Okay, now, and we talked about it, these two case scenarios is what the Keynesian model is about. Because Keynesian model is a model of the short run. Remember, short run in macroeconomics is not attached to a specific time frame. Short run doesn't mean 6 months or 2 months. It basically means that anytime the economy produces less or more than its full employment output, we say that the economy is in the short run. When the economy is producing at its full employment or potential output level, when all resources are fully engaged, then we say the economy is producing what? In the long run. So long run, again, is not 50 years or 20 years. It basically means that the economy is producing at its full potential or at its long run equilibrium value. So there's going to be price adjustments. So the idea here is that because when we derive the LM curve, we assume that prices were fixed. But that is going to change. So what we know for sure that, so if the three consider, if Y equals to Y bar, price tends to stay, or price stays is constant. Price doesn't change. But if Y is less than Y bar, we saw that from chapter 10, when the economy is in a recessionary gap, economy eventually is going to readjust back to full employment. And that adjustment comes through price movements. Price is going to fall. This is true. When the economy is in a recession, there's low aggregate demand because people don't have money. There's high unemployment. So aggregate demand is low. You know, people are not selling enough of their goods and services. The suppliers of goods and services will try to lower the price in a recession. So price will fall as the economy goes to what? To full employment. And if Y is greater than Y bar, if the economy is overheated, that means so many Americans have jobs. Higher income drives up aggregate demand. So price is going to rise. Price tend to rise as the economy transition back to full employment. So now let's talk about how we can derive the aggregate demand curve from the ISLM, because I told you earlier on that the aggregate demand, aggregate supply model is a watered down version of the ISLM. Okay, now we are going to allow for some, you know, when we talked about shifting the LM curve earlier on, because we were assuming that the economy was either in the short run where you're producing this or that, where price was sticky, price was fixed, we hold price constant, okay? So the only thing that was shifting the LM curve was when the Federal Reserve would increase the money supply, because remember, the LM curve, where's my pen? So all on a second. I got my pen working here. There you go. Okay, so the idea here is that when we're talking about the LM curve, I mean, before I start derive that, I want to make you put it in context here. The LM curve or equation is derived from the money market when M over P bar equals to the money demand function with MD over what? M, which is that, which we can write for folios M over P equals to P bar. The money demand function here is a function of interest rate and real GDP. So what we did was when we were deriving the LM equation, we did it or shifting the LM curve. We were holding price constant because we're assuming that the economy is in the short run when price is fixed. So that's when the Fed increased the money supply, this M over P would increase because P is constant. But now we're going to change. We're going to say that the economy does not stay in a short run forever. Eventually, price is going to start changing. For example, if the economy is in a recession, prices of goods tend to fall. So as price of goods fall, that's going to affect the real money supply as well. Okay, if the price falls, for example, that means M over P is going to be bigger. It's kind of like similar to the Fed printing money, but the Fed is not printing money in this case. Once price start to adjust downwards or upwards, the real money supply is going to be affected as well. So that means the LM curve is also going to shift to the right or to the left when price level start to what? To adjust. So that allows us to what? To derive the aggregate demand. Again, to remind you from chapter 10, the aggregate demand curve is a plot of combination of price level, aggregate price level, and real GDP. And the AD curve slopes downwards. You know that from chapter 10. So we're going to try to derive this this curve from the ISLM framework. So let's get to work here. So I say that the sub-heading there is deriving the what? The aggregate demand curve. So what you're going to realize here is that let's assume that D was your initial equilibrium between this, your IS and LM. You see, this is my all LM, this blue line, intersecting this black line, which is this point. So so we're going to assume that there's a price level because the LM curve is a function of M over P. See, M over P bar. So we're saying that's P1. This P1 that enters the LM curve when you derive the LM equation. So LM is a function of price as well. But then we're going to say that if this is a P1 in a real money supply equation that allows you to derive the LM curve, there's going to be a combination of P1 and this Y. So in this downer panel here, we're going to say there's a combination of Y and P. So we can locate the Y1 here and P1. So we get this first point on the aggregate demand curve. Now, let's say the economy was in inflationary gap. When the economy is in inflationary gap, prices tend to rise as the economy transition to what? To full employment. That's what I say here. When you're producing an inflationary gap, prices tend to rise. The inflationary gap means in short run, but prices don't stay fixed forever. Eventually, price is going to adjust as the economy adjusts back to long run equilibrium. So in inflationary gap, prices tend to rise. So when P rise, that means M over P, which is the real money supply, is going to fall. So the LM curve is going to shift to the what? To the left, because the real money supply has changed. Okay? Or in the aggregate demand, the price has gone up. Okay? So when the price goes up, the LM curve shifts to the left. That results into new equilibrium here. Interest rate goes up, GDP falls. That's going to be the same GDP. We're going to move along the aggregate demand curve when price change. So we move from this point to this point. See, so that means I'm going to get a new combination of price P2 and Y2. So if I join those 2 points, I come up with a downward sloping graph called the aggregate demand curve. The AD curve slopes downwards. Okay, so here's the deal. Anytime you are changing price, remember, so changes in prices in the economy will shift the LM curve, but will involve a movement along the aggregate demand curve, say from this point of view. If the price had fallen, that means the real money supply M over P. If this thing is falling, the Fed does not change the money supply, remember. So M over P would increase instead. That means the LM curve would have shifted to the what? To the right instead, like that. And that means interest rate, the new equilibrium would be here where GDP would rise to say Y3, and interest rate will fall to say R3. So in this case, we'll be moving along the aggregate demand curve. There's going to be another point here, which is going to be your Y3, and then there's going to be your P, like P or P3, whatever you would call it. So it's still moving along the same aggregate demand curve. So a change in aggregate price involves a movement along the aggregate demand curve, but it results into a shift in the LM curve. So that means when prices start to change, the LM curve will shift as well. Just like monetary policy or credit card fraud can shift the LM curve, which we discussed earlier. A change in aggregate price will also shift the LM curve, like you've seen in this whatever. Okay, so now let's talk about monetary policy and aggregate demand curve. So, but before I talked about that, now I wanna put like a note here, okay? Because we know that the aggregate demand, we already talked about this, which plots price and all. Let's talk a little bit about this. We talk about in chapter 10, the aggregate demand curve can shift to the what? Can shift to the right, like that, to AD2, or it could shift to the left, to like say AD0. So when we all price constant, see, we can get this output Y3, Y1, Y2, Y1. See that? So see, the aggregate demand curve can shift to the right, or it could shift to the left. And we know that fiscal policy, we talked about this in chapter 10, which involved like G, government spending and taxation, will shift the what? The aggregate demand curve. But in chapter 11, we also found that in chapter 12, it will also shift the IS curve. For example, if the government increases government spending, both the aggregate demand curve is going to shift to the right. The IS curve is also going to shift to the right. If the government decreases spending, the IS curve is going to shift to the right. Okay, so let me maybe I should draw them side by side so that you get to see what I'm talking about here, because sometimes if I don't describe the other one in words. So let's say, so it's like you're putting your AD curve here, one, which plots price and output, and then you can draw your IS curve plots interest rate versus income. The IS curve slopes downward. You can call this IS1. So all what I'm saying is that when you increase government spending, the aggregate demand curve is going to shift to the what? It's going to shift to the right, to AD2. Yes, at a constant, let's say price, so it's P. So this was your initial output, Y1, Y2. In the IS curve, if this was your interest rate, an increase in government spending is going to shift the IS curve to the right as well. See that? To IS2. See? So fiscal policy. So and then the converse is true. If the government had decreased spending, then the IS curve and the aggregate demand curve would both shift to the left. Like that. They would both shift to the left. Okay. So that's going to be the same thing. So I'm going to just say here, and then that's going to be similar to monetary policy. Okay. Monetary policy by the Federal Reserve. So suppose the Fed increase, for example, increase in what? In money supply, in M. Okay, where you're saying change in M is positive. This is going to shift both the aggregate demand curve to the right and the LM curve to the right, right? So you got Y, then you got, this is your IS LM framework, IS. And this is interest rate, real GDP. So this is your AD curve. Okay, this is your, sorry, I'm talking about the LM because monetary policy affect the LM, not the IS, so interest rate. So the LM curve is upward sloping, AD0. So for example, if the Fed increases the money supply, the AD curve is going to shift to the right. Okay, and the LM curve is also going to shift to the right. Okay, so monetary expansion by the Federal Reserve will shift both the AD and the LM curve to the right. When the Fed does a monetary contraction, let's say they decrease the money supply, then the LM curve is going to shift to the left, and the aggregate demand curve is going to shift to the left. Okay. So now I'm going to write just one main point here that anything, okay, with the exception of price, anything which shift the LM curve left, or right will also shift the aggregate demand curve to the left or right. Okay. Or we can say in the same direction. Okay. And then you can write a second note there saying that also, so anything which shift the IS curve left or right will also shift the AD curve in the same direction. For example, an increase in government spending that I talked about will shift both the IS and the aggregate demand curve to the right. A decrease in government spending, contractionary fiscal policy will shift both curves to the left, both the AD and the IS curve to the left. Okay. So now, this is exactly what we're talking about. If the Fed increases the money supply, we know that, so we're holding price constant, P1, because in the short run. So this was your initial terminal equilibrium point when the LM curve 1 intersect with the IS curve. So the terminal equilibrium values on interest rate is R1 and Y1. So when the Fed increases the money supply, in the short run, holding money supply constant. So then we're also going to assume that this is your corresponding aggregate demand function down at AD1, where price is P1, Y1. So when the Fed increases the money supply, you know the LM curve is going to shift to the right. That's going to lead to this equilibrium, new equilibrium, where equilibrium output is going to increase and equilibrium interest rate is going to decrease. Okay. And then in the aggregate demand function, you can see that you can see that the AD curve is going to shift to the right as well because of that monetary expansion. And the converse is true. So I gave you this table already before. So in the Keynesian model, while Keynes argues that the economy is a model of the short run, Keynes is not suggesting that the economy stays in the short run forever. Okay, he's just arguing that we need to care a lot more about the what? About the short run, you know what I mean? So when the economy start to adjust from a recession, for example, to full employment, prices tend to fall. Over time, prices fall. That's what I say. So here, you see P falls. Here, P rises. P stays the constant because over time, the price level will rise when output is above full employment and fall when you're in a recession, remain constant when the economy is already in full employment. Okay. So now, let's talk about the short run and long run effects of an IA shock. Remember in chapter 10, I said you can use the aggregate demand, aggregate supply model in chapter 10 when we did not have the ISLM to analyze the short run and long run effects of different shocks, demand shocks, negative demand shocks. So now we're gonna be combining both framework, the aggregate demand, aggregate supply model. Okay, so here's what before I even go to analyzing that, let's assume that the economy was at full employment. That meaning that the actual short-run output that the economy was producing was equivalent to its full employment value. That's where we want the economy to be, always. So just hold on a second. Let me check something here on my pen. Okay, I gotta share back. Okay, so let's say, so when the economy is in full employment, so I'm gonna draw two frameworks. The ISLM framework, and then the aggregate demand and supply framework of chapter 10. You already know aggregate demand is, we already derived it from the ISLM framework. So this is going to be something like, so let's say this is my IS, which plots interest rate and real GDP. So I'm going to assume that this is my LM curve, and this is my IS curve, okay? And then these are the terminal equilibrium values, Y1, R1. And we're assuming that in the aggregate demand, aggregate supply model, which we saw in chapter 10, we're saying that the economy is producing actually at full employment. So this kind of like full employment value. This corresponds to this guy. This, you can go up like this, long run aggregate supply curve. In the, because we know this line is long. In the aggregate demand supply model, we put price here, we put output of chapter 10. So this is your Y bar. Y bar means I can run a room there. And then this is going to be your aggregate demand. And then we know short run aggregate supply curve, remember, is perfectly elastic, you can call this. So that this is a long run. We're saying that the economy is producing long run equilibrium. So the short run, because the ISLM tells you the short run equilibrium, we're saying that short run equilibrium is exactly on the long run, meaning that the economy is at full employment. That's where we want to be. But the economy is going to be disturbed. There are several macroeconomic shocks or disturbances that tend to push the economy away from its long-run equilibrium value, okay? So let's talk about how the economy will adjust, what the short-run effect of such shocks would be. For example, let's discuss the impact of an IS shock. So in this example, I'm going to use, anything that shifts the IS curve to the left is a negative IS shock. You also shift the aggregate demand curve to the left. For example, let's say, suppose Congress cut spending. So that's a shock. Okay, it's a negative IS shock. The IS curve is going to shift to the right. So I say use both the IS, LM, and aggregate demand, aggregate supply framework to analyze the short run, the short and long run effects on interest rate, price, and real GDP. Okay, I want you to mark my word here. I'm asking, and I'm going to ask you this similar question on the test. If I ask you to use the ISLM and the ADAS framework, right? And you're only drawing one diagram, ISLM, and you forget the second one, that means you fail. The question is clear, saying that use both of them in your analysis. So here's what you're going to do. First of all, we know that anything that shifts the aggregate demand curve to the left will also shift the IS curve to the left, which is, example include cutting spending. When there's a decrease in government spending, that's contraction of the fiscal policy. That will shift both the IS curve to the left and shift the AD curve to the left. That's going to push the economy away from its long-run macroeconomic value. So your main task is always, your starting point always, you need to draw the IC. This is going to be your initial IS. See where the two blue lines intersect. We're assuming that short-run output, the economy, then we draw the aggregate demand aggregate supply model. Long-run output is when aggregate supply curve short-run, aggregate demand AD1, and long-run aggregate supply curve, they're all intersecting at one point. And this output that is here corresponds to that. So the short-run output is on its long run. The economy is at full employment. And then all of a sudden, we get a negative shock to to aggregate demand. Government cut spending. So we know that the IS curve is going to shift to the right, sorry, to the left. And the LM curve is going to, the aggregate demand curve is going to shift to the left as well. So you can see that, so that in the short run, you can document the impact here right away. Because, if this was your initial, I didn't label this. This is your initial interest rate, R1. Okay. Now, when when government cuts spending and the IS shifts it to the left, see, interest rate falls to R2. I see. In the short run, price is sticky. So price doesn't change. When you shift the AD curve to the left, we talked about that in chapter 10, but output is going to fall to Y1. So now you can see, because this is full employment output, when the government cuts spending and agri-demand curve shifted to the left and the IA shifted to the left, we are going to be in the short run, because now the output we are producing is not on the long run agri supply curve, because a shock typically pushes the economy away from its long run equilibrium value. So when I ask you to document the short run effect here, you have to document immediately you shifted those two curves to the left. The short run effects are going to be, you see it clearly, that P stays constant in the short run. When you shift the AD curve to the left, interest rate falls. See that? It falls from R1 to R2 because we are this near equilibrium. And then output Y falls. Those are your short run events. But as we say, the economy is not going to stay in a recessionary gap forever. There's going to be adjustment back to what? To full employment. So that just what happens. So now we know, you know the story. Now, the story is that if Y1 is now less than Y bar, okay, when the economy is in a recessionary gap, there's high unemployment, wages tend to fall. As wages fall, the short run of the supply curve is going to shift downwards, meaning that price will fall. Shifting the short run agri supply curve downwards. Okay, so when you go back here, look, what is happening here now is that when the economy is in a recessionary gap producing this output level Y1, remember, this is your R2. This was your R1. Okay, price eventually is going to start falling. See that? And as price falls, your short run agri supply curve is going to shift downwards to short run agri supply curve too. So the economy ends up at this point. Okay, so in the long run, as economy transition to the long run, price is going to fall. But as price fall, remember the we are on this point on this point of equilibrium. Okay, when price has to fall, remember the LM curve is a function of price as well. LM curve is derived from the money market equilibrium M over P. So as price falls, the real money supply is going to increase, meaning that the LM curve will eventually shift to the what? To the right, to LM2. This LM2 is correspond to is a function of P2 because price has fallen. So we end up at this point. So the interest rate will even fall further to R3 in the ISLM framework. So when you're documenting the long run effects here, is that P falls in the long run and interest rate further falls from R2 to R3, and then there is no change in GDP in Y. Because remember, we started from this point, and when we had a negative demand shock, the agri-demand curve shifted to the left because of a cut in government spending. So there was only a temporary effect on what? On output. But as economy adjusts back in the long run, we are back on the long run against supply curve. So there's no change in GDP. Same thing here. In the ISLM framework, we started from here, we move here, then the LM curve is going to shift to the what? To the right. So we're back on the what? The same output we were producing before the what? The cut in government spending. So the long run effect on output is going to be zero. So this is the adjustment that I'm talking about. See, so it's a gradual shift, but I just did one shift because when you're drawing in a graph, you can't draw it like this gradual shift. You just draw one shift from P1 to P2. This curve goes downwards, right? So at the end of it all, you see this is what you're going to be drawing like in a test to see how you adjust to the long run. See, the LM curve eventually is going to shift to the right. This corresponds to what I already drew here. See what I drew here? The LM curve shifts to the right, you move here, but it's more clear in your PowerPoint slide. The LM curve, why is the LM curve shifting again? Because as price starts to adjust, the LM curve is just a function of price. When price is falling, the real money supply is going to increase, shifting the LM curve to the right as well. Meanwhile, the short triangle supply curve is going to shift downwards as price adjusts to the long run. So we end up this point. Okay. So this process continues until the economy reaches the long run equilibrium. Okay. So let's do one more example of such shocks again. Let's do a monetary shock. There's what we call let's say, suppose the Federal Reserve pursues an expansionary monetary policy. Okay, so that means the Fed is increasing the money supply. So delta M would be greater than 0 in that case. If the Fed is pursuing an expansion, so then I can say use the ISLM and AD, aggregate demand, aggregate supply model frameworks to analyze the short and long run effects on interest rate, output, and price. So here is not government spend, not Congress decreasing spending. Here the Fed is increasing money supply, is a monetary expansion. And I said, here is always going to be your starting point. If you cannot draw the starting point, that means you're going to fail this. That means you can't even start. Okay. So your starting point, you're going to draw. No, I don't want to use red. Let's use black here. So this is my lines are crooked, but okay. So this is your ISLM framework. Put Y there. So if this is my LM1, which is now a function of M over P, M1 over P1, you can put that. And then this is my IS curve, IS1. So this is my initial equilibrium values. Output. We're assuming that this is the economy is producing. Our short run is on the that's where you begin when the economy is producing at full employment. So we're going to match it up with the aggregate demand, aggregate supply framework here. See? In the aggregate demand, aggregate framework, we are plotting price versus output. So that's the same output that determines your long run aggregate supply curve. And then the aggregate demand slopes downward. You can call this AD1. And then this is your short run aggregate supply curve. You can label it SRS1. This is your P bar 1. This is your Y bar, which corresponds with. So this is like essentially, this is your long run. Okay, so we start from here and protrude to the diagram on top. Okay. So you could label this point, say this is my point A. And then I can label this down a point. You can call it corresponding A prime. Now we've been told that the Fed has increased the money supply. So when the Fed increases the money supply, that means the LM curve shifts to the right to LM2. The new money supply is now M2 over P1. So in the short run, and then we know that anything that shifts the LM curve to the right, that's going to lead to an increase in output already. You can call this Y2. And interest rate is going to fall immediately in the IS framework. See that? Okay. So the same thing is going to mean that anything that shifts the LM curve to the right, we already talked about it, will also shift the aggregate demand curve to the right to AD2, right? So we can label this point B on the ISLM, and then label this point B prime on the aggregate demand. See, so the economy is going to produce more than what? Beyond full employment. Okay, so immediately you shift the LM curve and the AD curve to the right. You need to document the short run effects. So the short run effects here, that in the short run, you can say short run effects is that you can see clearly P is constant. P doesn't change. The interest rate falls and output Y increases, rises. Okay, but now the economy has been pushed away from its long run equilibrium value Y bar that we are now producing beyond full employment. So that's what we call an inflationary gap, when output exceeds full employment. So when the economy is overheated, you know that the adjustment is anytime actual output exceeds full employment. We talked about it over and over. Price is going to start rising as the economy adjusts to its new long-run equilibrium. So here, as the economy starts to adjust to new long-run equilibrium, price is going to rise. And it's going to that's going to prompt the short-run aggregate supply curve to shift to this new level, SRAS2. So you can label this P2. So the economy ends up back on the long run where we started from at point C prime. But as price starts to increase, remember the LM curve is also a function of price. When price, even though the Fed had increased the money supply M2 leading to a shift of the LM curve to the right, that led to short-run equilibrium interest rate falling and output rising. When price starts to increase, that means the real money supply falls, so the LM curve is going to shift backwards. So we go back to this point where we started from. So now if you're documenting the long-run effect of that monetary expansion, the long-run effect is going to be that as economy, long-run effects is that price rises, GDP stays the same. And then interest rate stays the same in the long run. That's right. There's no change in interest rate long run. The long run effect, because we started at point A, we shifted the LM curve to the right, and we shifted the AD curve to the right. So that only had a temporary short run effect on output and interest rate. Interest rate fell and output went up from Y1 to Y2. But as price starts to rise in the economy, the LM curve is going to shift upwards. So that is going to close this recessionary gap, and output is going to be back to its long run where we began, and interest rate is going to be back from where we began. So this is what we just described. There is what we say. There's a common concept in macro which we call it the what? The doctrine of long run monetary neutrality. Monetary neutrality, which says that money has no long-run effects on real variables. And the real variables in here are going to be our interest rate and what? It only what? It only causes prices to rise in the long run. Price on nominal variables to rise in the long run. Okay. So here's exactly what I'm trying to, what I just talked about here. Money is neutral in the long run. So when the Federal Reserve increased the money supply, remember the first thing that happened, the money supply increased from M1 to M2. We shifted this to the right, and we shifted the what? The AD curve to the right as well to AD2. But so the short run effect was that output was increased. That's exactly what I drew there. And price went up. Output rise, interest rate went down because the LM curve shifted to the right, following a monetary policy shock. But over time, as the economy is producing beyond full employment, the adjustment is going to be that price will rise from P1 to P3. So the economy is going to adjust to this point, and the LM curve is going to shift to the left. Okay, because the LM curve is a function of price as well. When price has to rise as the economy transition back to full employment, that means the real money supply falls, shifting the LM curve left to where it was. So in the end, there's no effect, there's no change. That's where we started from. That's where our R1 was. Okay, the economy we started from there, it wiggles around, then it goes back there. In the agri-demand curve, we were at this point to begin with, and then we move here, and then we are now here. Okay, so the only thing that has been affected is price. Price went up in the long run, but we are back to long run output. Output does not change. So that's a neutral. Money is neutral in the long run, it doesn't change real economic variables. There's one thing that I want to talk about before we end here. Then I'm going to kind of show you a little bit what is on your slide. Another additional practice problem. So now that you have learned how to derive the aggregate demand curve, recovering it from the ISLM framework, and you can analyze the impact of shocks. So during your free time, make sure you practice drawing these graphs, analyzing the impact of those shocks the way I've explained here. We have done one case where the Federal Reserve was increasing the money supply, this last case. Then the other case was a case where Congress was decreasing government spending. But you can try a different example. You can say, what about a case when during your free time, what about if Congress had increased government spending? Draw it. Because that would make, because remember, anything that shifts the aggregate demand curve to the right will also shift the IS curve to the right. Anything that shifts the IS curve to the right will shift the AD curve to the right. So when government increase spending, we know both the IS and the IS and AD curve are going to shift to the right. So there's going to be a temporary short-run effect on output, but the economy eventually is going to adjust back to full employment. So output will not change in the long run. You only have like a long-run impact on price. So practice those diagrams. So now, while I showed you how to derive the aggregate demand curve graphically from the ISLM, I also need to show you how to derive it now numerically using numbers, because aggregate demand curve slopes downwards. It's a function that relates price and output, meaning that there must be an equation that represents that AD curve. The aggregate demand curve only will plot combination of price and output. So, so now what I'm going to do here, I'm going to show you how to derive. My pen is kind of acting up weird. It's not fully charged yet. Make it work. So, I just want a little bit. So, but again, you want to practice and practice and practice. Make sure you practice the what? Because I'm going to go over a little bit after I show you do how to derive this aggregate demand numerically. I'm going to go to the second practice Q&A. It's labeled at Canvas practice Q&A, chapters 11 through 12. You see, you want me, I distributed it in class yesterday. So if you were not in class yesterday, remember I gave an additional practice problem. You see, you can still locate at Canvas. If that's what, okay. So let's talk about deriving the aggregate demand function numerically. We have to know how to derive it using what? Using a graph, but we can use so here's whatever. Since the AD curve relates, it's a function that relates P and Y. Yeah, you know it's here. We just derive, we know it. You put P here, you put output here, AD curve slopes downwards. So to derive the AD function, we substitute the IS equation into the LM equation with an undetermined price. What do I mean by this? So even if I gave you the value of price to be 2, you're going to leave, you don't substitute that P, you leave P in the function. We want P to remain in a function. So I want to do one example before I start doing that. Remember the earlier example of slides 11, the Q&A. We had what our earlier examples. We said the money demand function was given as MD over P was given as Y minus 100 off. And then we say that the money supply was 1,000, remember? And price was 2. And then I gave you a couple of other, then I also we derived the IS equation. Remember, we did that. Our IS equation, if I remember correctly, was given as Y equals to 1,700 minus 100R, remember? And then the LM equation was Y equals to, I believe it was 500 plus 100R. Okay, so the aggregate demand curve only relates P and Y, meaning that there's no interest rate in it. You need to get rid of interest rate. So to derive the aggregate demand curve, you need to, so in the IS equation, this equation here, you can make R a subject. You can write this equation as, if you take 1,700 to the left-hand side, subtracting both sides, and then divide all through by negative 100, you're going to find that your R is the same thing as 17 minus 0.01y. That's the same thing. I just wrote it differently. You know, this is your IS equation here when I make R a subject. Now, to derive the aggregate demand curve, as I told you, you're going to substitute this value of the IS equation for R into the LM equation, but with an undetermined price. So that means you need to rewrite your LM equation. Okay, so your LM equation was derived from where? From the money market equilibrium. We're saying that MD over P equals to M over P. Because to derive the aggregate demand curve, you must leave P in the function. So that means my money demand function is given, this guy is being given in a problem, is given as that. So I'm going to substitute it here. So that's Y minus 100 all must equal to, then I'm going to say M is 1,000, but I don't substitute P. That's what I mean by an undetermined price, because P has to remain in the function. Now, this is your LM equation, but without substituting for P. Now, what I'm going to do, I'm going to substitute the IS equation, which is this guy, for R into this LM equation. So if I substitute the IS, okay, call this equation 2. I say substitute the IS equation in equation 2. Then what we're going to find is that you're going to find that your Y, let me first duplicate it here. 100R equals to 1,000 over P. So that means Y minus, now 100, if I substitute the LM equation, the IS equation is what? R is given as 17 minus 0.01Y. Yes, must equal to the right-hand side, which is 1,000 over P. Now I clean up, now distribute these things inside. So you get Y equals to 100 times 1,700, that is 1,700. Negative 100 times negative 0.01. That's going to be what? That's going to be positive. So this is supposed to be Y minus. Yeah, so minus sign here. Negative times a negative, that's going to be positive. 100 times 0.01y is just going to be Y equals to 1,000 over P. Then now Y plus Y, that is 2Y minus 1,700 equals to 1,000 over P. Okay, and you can do a little bit or whatever. You can see already, you can actually leave your expression here on using this, leaving it in this expression if you want to leave it. But you can do a little bit of cleanup if you want. If you leave it there, I can see the inverse relationship. This is your AD function. Because the aggregate demand function shows an inverse relationship between price and output. But I want to clean it up a little bit. If I divide all through by 2, you get y here minus divide by 2 here. That's going to be blah, 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 850 must equal divide by 2 here is going to be 500 over P. And then what I could do, I can do a little bit of cleanup. Again, second step, I can get the inverse of both sides. I get the inverse. So let me first duplicate this. This is y minus 850 equals to 500 over P. So if I take the inverse of both sides, that means I can write this one as P over 500 equals to 1 over y minus 850. Okay? And then what I'm just going to do a little bit of magic to it. So if I don't magic, just so we're going to say if I multiply both sides by 500, this guy is going to cancel. So P is going to be equals to 500 over y minus 850. You can leave it in this form because that already shows an inverse relationship that the aggregate demand curve slopes downwards, right? P here, y here. When y goes up, P goes down. When P goes up, Y goes down. So inverse relationship. You see that because this is at the bottom. So that's how you derive the aggregate demand curve. So now, briefly, I'm just going to go quickly to there are a couple of things you need to know here. I'm going to open my that handout, which you're supposed to know, which is a second handout Q&A posted at Canvas. So let me go back here. So under my course modules, so you're going to see practice questions on ISLM in parentheses, chapters 11 through 12. So let me open that. Okay, then I'm going to share my screen on the other side. Okay, see, that's the practice problem. So this and probably my digital pen doesn't allow me to write on the, this is like a PDF page. So I'm just going to help you see what they were. So I was saying, consider the following Keynesian economy. Labor, and you can disregard the time subscript. You can write just L without the T, because I like to do dynamic models. So always sometimes I forget and leave those time subscript on the variables. You can just write L equals to 121, forget about the T. A is 1, K is 196. And then this is your production function, which is a Cobb-Douglas production function. And then I gave you the consumption function, which is given by that. Investment function is 50 minus 200 R. Government spending, G is 34, T is 34. And then I gave you the money demand function. Remember, MD over P is 5Y minus, as I said, disregard the time subscript all through. And then the money supply is 2480, price is 4. And then I say, use the above information to answer the following questions. Find an expression for the IS curve. Okay. Just a little bit. I want to transfer this information back into the what? Back into the my slides. So I'll just all bear with me just for a second here. Let me go back here. First of all, I want this so that I can see it. Print it out here. Okay. Okay. So I have L 121, A is 1, K is 196, Y is K 0.5, AL 0.5, C is 6 plus 0.7, Y minus T, I is 50 minus 200 R, G is 34, T is 34. Money demand function is given as 5Y minus 1500 R. MS is 2480. P is 4. Okay. So now let me go back and We should go back to our slides. And confront that there. So the question has been, we have been told that, you know, I gave you some economy, and that economy, the labor force, L, is 121. I say you can ignore the time subscript. And then I gave you A is 1, technology parameter, K is 196. And then the production function is given as K to the 0.5, AL to the 0.5. And then I gave you the consumption function, which is given as 6 plus 0.7 into Y minus T. Oh, sorry, Y without a bar. It's T, which has a bar. And then investment function is given as 50 minus 200 all. And then I gave you government spending is given as 34. And T is also 34. Okay. The money demand function, P equals to 5Y minus 1500 all. And then the money supply is 2480. Price is 4. Okay, you might want to print, once you reach this time when I'm doing this problem, have that problem that you have at what? You have a canvas. You want to print it and have it in front of you, so that when you're following what I'm doing, because I'm going to be going back and forth, referring to several questions that I asked on that handout. Let me look for my copy here as well, so that I don't have to keep going back and forth on that. Second. Okay, got it. Okay, so now the question says we should use this to derive the formula for the IS curve. So that is A, Roman 1. We need to derive the IS curve, IS equation, expression for the IS curve. So we know that the IS curve comes from the goods market equilibrium. Very simple. So when you're deriving it, the IS curve, just invoke, like we did yesterday in class, invoke the goods market equilibrium. Goods market equilibrium, which says that Y equals to C plus I plus G. That's right. Then you're going to substitute the known values. Get another pen here. So so that means Y is going to be equal to your consumption function has been given in the problem. Consumption is given here already, is 6 plus 0.7 into Y minus T. So you're going to substitute it there. So it is going to be 6 plus 0.7 inside Y minus T, but let us keep T there. Then plus the investment function. And it's tripping again. So the investment function is given us 50 minus 200 R plus G. Now then I'm going to substitute. That means Y equals to 6 plus 0.7 inside Y minus the T has been given at 34. Taxes are 34 plus 50 here minus 200 R plus government spending is also 34. Okay. Then we open that bracket. So Y is going to be equal to 6 plus 0.7 times Y. That's going to be 0.7 Y. 0.7 times minus 34. So that's going to be, I need my calculator here. Yes, 1 second. It'll be 28 maybe. Let's see. I just want to be, I don't want to make mistakes. So that's going to be 34 times 0.7, 23.8. So this is going to be minus 23.8 plus 50 minus 200 R plus 34. So now you add the constants together. So you get 6 here. You got 23.8. You got 50. You got 200, you got 34. So 34 plus 6, that is 40. Okay, remember this is 200R. This you can add because this is a variable, R in it. So 34 plus 6, that is 40. 40 plus 50, that's 90. So 90 minus 23.8 is 66.2. So you're going to have Y equals to 0.7 Y plus 66.2 minus 200R. And then you got to collect terms in Y, take 0.7 to the left-hand side. Yeah, we did it yesterday. You collect those terms in Y, put them in one side. You're going to have, I'll put a new slide here. You're going to have Y minus 0.7 Y must equal to the right-hand side, which is 66.2 minus 200R. So Y minus 0.7 Y, that is 0.3 Y must equal to 66.2 minus 200R. So I can take 66.2 to subtract 66.2 from both sides. So you're going to have negative 200R equals to 0.3 Y minus 66.2. Then I'm going to divide both sides by negative 200, divide all through by negative 200, negative 200. So negative divided by negative and later also R is going to be equals to, so negative 66.2 divided by negative 200. There's going to be a positive number. 66 negative divided by negative is a positive. Divide by 200. So that's going to be 0.331. And then 0.3 divided by negative 200. That's going to be a negative number. So 0.3 divided by 200. So that's going to be negative 0.0015 Y. This is your IS equation. If I ask you to get the slope of this IS equation after you made R a subject, you just say slope. I might not have asked you. You take dr, dy, take the derivative. This is just going to be the coefficient on y, which is going to be negative 0.0015, which is less than 0, because the IS curve slopes is negative slope. When you put R there, y here, you know it slopes downwards. Okay, and then part Roman 2 of part A, it asks you to derive the formula for the LM curve. Now, again, at this stage, you now know the LM curve comes from the money market equilibrium. So to derive the formula for the LM curve, you're going to invoke the money market equilibrium that says MD over P must equal to MS over P. Okay. The money demand function has been given. You go there working at a problem, MD over P is given as 5. So you substitute here is going to be 5Y minus, again, drop the time subscript, the T's. You don't need to put the T's there. 1500 R equals to, the money supply MS is given us 2,480 divided by price, which is 4. The LM curve is the easiest to derive. So you get 5Y equals minus 1500 R must equals to so here's going to be 4 goes here one time, 4 goes there, 6 6 no, yes, go there 6, then 2 0, so it's 620. Yeah, just check, make sure it's true. 2480 divided by 4, yeah, 620. And then now make R a subject. So you're going to say, you take 5Y to the other side. So you get negative 1500 R must equal, subtract 5Y from both sides, equals to 620 minus 5Y. Then I'm going to divide all through by negative 1500 because I want to make R a subject. Negative 1500, negative 1500. Okay, so once I do that, then your final equation, which is the LM equation, is going to be So the left-hand side, negative 1500 R divided by negative 1500, that's going to be R. 1500 cancel. 620 divided by negative 1500, that's going to be a negative number. 620 divided by 1500 by negative, that is going to be negative 0.413. And then negative 5y. Negative 5y divided by 1500. This is like dividing negative 5 by negative 1500. You get a positive number. 5 divided by 1500 is 0.003. So that means, but positive, plus 0.003. You round it like that. So this is your LM equation. And you can see in the whatever I did, I skipped some step, but I'm going now step by step to allow you to understand. When you go to the solution of that, you can see that we have found the same thing. There, the LI's equation is what is given by that. Yes, yeah, that's true. That's correct. And again, you can drop the time subscript. And then the question B, part B said, find an expression for aggregate demand function which relates price and output. We just talked about it. It's the aggregate demand function. Remember, you substitute, again, this is how you derive the argument. You substitute the IS equation into the LM equation with an undetermined price. That means you don't substitute price because you want the relationship between price and Y to remain in that function. So that means to do the aggregate demand function, you need to somehow kind of rewrite your what? Your LM. Because you know that your LM equation, which was easy to derive, we know that it comes from MD over P, minus real minus demand equals to real minus supply, right? So we are not going to substitute price. Minor demand function is given as what? 5y in that problem minus 1500 R. So that's just this guy on the left must equal to the minus supply is 2480. But then we don't, even though price is 4, that's what I mean by with an undetermined price. Let price remain in the function. And then now what we do, this is your LM, but we have no substitute for price. Now we substitute the IS equation, then the IS equation has already been expressed in a way that we want, where R is a subject, we derived earlier. We're going to substitute this IS equation for R into that LM equation in here. So that means if we substituting the IS equation, then this becomes 5y minus 1500. So where there's R, we're going to replace that with the what? The IS equation. The IS equation is given as, again, we found it to be 0. I want to make sure. I think it was 0.331. There you go. Minus 0.0015 y. Okay, so this must equal to the right-hand side, which is 2480 divided by P. When I clean this up, this is going to be 5y. Then open this bracket. So 1500 times 0.331. Just use your calculator. And by the way, you got to bring the calculator to the test. You can't come to this type of class exam without a calculator because I won't let you use the calculator on your phone. In fact, your phone must be turned off during the exam. That's the class policy. Every Texas State University class has that policy. When you're doing the exam, you can't have your phone on. What did I put in there? Yeah. So this is 1500 times 0.331. So the answer I get here is 5y minus 1500 times 0.331 gives you 496.5. Then minus 1500 times minus 0.0015. That's going to be positive 1500 times 0.0015. That is 2.25. Y must equal to 2480 over P. Then we just clean up a little bit for the expression for the aggregate demand. So the next slide, so you're gonna have 5y. Let me duplicate it here. What we found is 5y minus 496.5 plus 2.25 y equals to 2480 over P. So 5y plus 2.25y, those are like terms. That's going to be 7.25y minus 496.5 equals to 2480 over P. I like to clean things nicely. So what I'm going to do in the next step, I can take the inverse of both sides. If you take the inverse of both sides, then you can write this as P over 2480. The inverse of 2480 over P divided by price. You take the inverse, is P over, then that means I must take the inverse of the left-hand side, which is going to be 1 over 7.25 minus 496.5. Then I'm going to multiply both sides. Cross multiply both sides by 2480. If I multiply by 2480 here, 2480 here, these guys cancel. Okay, so that means P is going to be equals to 2480, then it goes there, 2480 divided by 7.25 minus, this is Y, by the way, Y minus 496.5. Now I want to clean a little because these numbers are huge. An equation, okay, if I have the right-hand side, I can divide the numerator and the denominator by 1 over 2480. Then I divide by 1 over 2480. I'm not changing anything. Because after all, this can cancel is equal to 1. But what I'm going to do, I'm going to distribute 1 over 2480 here. It's like 2480 divided by 2480. That gives me 1. The numerator then becomes 1. If I do that mathematical manipulation to it, because I want it to be a nice little, so you're gonna get P equals to, so the numerator now becomes 1 divided by, now the denominator is where I need to work. I'm gonna there's gonna be 7.25 y times 1 over 2480. So like you're dividing 7.25 by y by 2480, and then minus 496.5 times 1 over 2480. So the first term is gonna be 7.25 divided by 2480. You get, okay, so I get 0.0029. Okay, and that has got a y in it. Then minus 496.5 divided by 2480. 496.5 divided by 2480. I get 0.002. 0.2002. So this is my aggregate demand curve. So P equals to 1 over 0.0029 y minus 0.2002. See, that's an inverse relationship between price and what? Quantity. But output. So if you go to your slides, you actually find that aggregate demand function right there. I derived it already. Yes, it's right there. It's correct. Again, drop the time subscript. You don't need that. And then the other thing, that question that I asked you was, which is part E. I said find the short run. Find the short run is part E. Values of P, R, and Y. Okay, you don't need to solve for P. You're just going to say that we know that in the short run, so solution, in the short run, price is sticky. Price is going to remain the same at 4. Price doesn't change in the short run because the value of price has been given. But for R and Y, we know, how do we get the short run output and interest rate? Again, don't forget, to find the short run equilibrium output, you're going to be solving simultaneously the LM equation that you derived in part A and the IS equation for these values here. This output equilibrium, our short run equilibrium output and interest rate, meaning that you're going to solve the IS equation and the LM equation simultaneously. So we know that the IS equation, again, which you derive in part A, is given as R equals to 0.331 minus 0.0015 Y. And then the LM equation that you derive in part A, Roman 2, was R equals to negative 0.413 plus 0.003 Y. So to solve for R and Y, short run values R and Y, set the right-hand sides of the IS and LM equal. Because the same interest rate equals to that same. So set the right-hand side. So that means 0.331 minus 0.0015 Y is set equal to the right-hand side of the LM equation, which is negative 0.413. Don't make sure you don't make mistake, because any small mistake, you're going to be off. All your numbers are going to be wrong. Make sure you always check your work. And then now here, I'm going to collect collect terms in Y together, collect terms in numbers together. So I'm going to add 0. Because there's a negative on 0.413. If I add it both sides, so that means the left-hand side is going to be 0.331 plus 0.413. Then add this to the both sides. Then you take it to the other side, it's going to be 0.003Y plus 0.0015Y. So if you add this guy, this becomes 0. I believe 744 must equal to 0.00. This is going to be 0.0045Y. So if I divide both sides by 0.0045 by 0.0045, you find that your Y, your short run output is going to be 0.744 divided by 0.0045. It's 165. Oh, it looks like I made a mistake. Made a mistake. I might have made a mistake somewhere. 0.003. Yeah, because remember, I know where the mistake is. Remember we rounded too quickly, so these things are not matching. We need to round them in the same. This was like 0.00333. So it has to be the same decimals for you to get the precise value. So if you round all of them to the same decimal point, actually you go back to your IS, that's the same thing. So your IS curve should actually be, the LM curve. So when I round too early, should be R equals to negative 0.413 plus, this should be 0.003. I just stopped there, but you add another 3 here. That's going to be Y. So that when I add this, when I was trying to add it here, you're just adding the another 0.33 here. See that? So when you add, because when you add 0.33, 0.0033 Y to 0.0015, there you go. You get 0.0048 Y. There you go. And that must equal to 0.744. What was it? No. What was it? Where's the other one? Add 0.744, that's right. So it's going to be 0.744. So if I divide now both sides by 0.0048, 0.0048, it should be a much smaller. 0.744 divided by 0.0048. Yes, so you get y equals to 155. There you go. And then to solve for equilibrium real interest rate, you use either the IS or the LM. You can use the IS, which is given as 0.331 minus 0.0015y. So R is going to be equal to 0.331 minus 0.0015 times 155. Okay. 155 times 0.0015 and subtract from 0.331. Yes, so you get R equals to 0.0985, which is the same thing as about 9.9%. Or you can say, if you don't round, it's going to be 9.85. 1 decimal point to 2 decimal point. I'll take all that. Whatever you round it to, that doesn't matter. Okay, and then there's another question that say, solve for the long run price, interest rate, and y. Okay, now what you gotta know is that the long run output is determined by the production function, because in the long run, remember this is like classical model, output is a function of capital and labor. So to solve for the long run output, y, you need to use the production function. So y equals to, we have been given this as k, production function was given as k a l to the 0.5. Again, drop the time subscript, the t's that are put here. So your long run output is going to be, the value of k was given, I think it was given as 196. It's 196 to the power 0.5 times a was given as 1 times 121 raised to the power 0.5. Okay. Okay. 196 to the power 0.5, that's the square root of 196. Is 14. And then this is going to be 1 times 121 is 121. 121 raised to 0.5. The square root of 121 is 11. So this is going to give me, so 11 times 14. So 11 times 14 is 154. Okay. So you can see clearly your actual output is below full employment. Your full employment is below actual output. So I'm going to show you something. Okay, now to show that to derive the interest rate, because when output, short run output and long run output are not the same, that means price is going to adjust. When price adjusts, the LM curve shift. So you cannot use the LM curve to solve for long run interest rate. You must use the IS curve. So to solve for the long run interest rate, you're going to use the IS equation. The IS equation is given us, we derive this value 0.331 minus 0.0015y. So that means long run interest rate is going to be 0.331 minus 0.0015 times 154, which we just solved for. So that interest rate comes to 154 times 0.0015, then minus 0.331. It's 10%. So the long run interest rate is 0.1 or 10%. And then the long run price, you're going to use the what? You're going to use the aggregate demand. Aggregate demand function, we already found it to be what? We found P to be equals to 1 over 0. What I think we did it earlier. You know that. Let me not write something else. 0.029 0029y. Yes. The aggregate demand curve is 0.0029 y minus was it 0.2002? Yes. 0.2002. 2002. So to get a long run price, you're going to substitute the long run output in the aggregate demand function here, 0.0029 times 154 minus 0.02002. If you do the math, this is going to be the same thing as, I think it's 4.08. What did yeah, in your handout, that's what it is. Yeah, it's going to be, sorry, going to be 4.008. Okay. So theoretically, this is what is going on. If I ask you to illustrate all your solution in a graph, this is what you have found. You found that I wanted to draw. You want to do the ISLM using numbers now. So you found this. This is what you found. This is your interest rate. This is your Y. When we solve for the short-run equilibrium value, this is your IS1. This is your LM, which is a function of price 1. You found this initially. You find this to be 9.85%. And you found this to be 155. So, but now if I embed the long-run aggregate supply curve, which plots price and quantity, you found that the full employment long-run output was at one. This like Y bar is 154. See, so your actual output exceed full employment. So that means the intersection between aggregate demand, see, short-run aggregate supply curve. Oh, no, you shouldn't do it. Okay, so that means the intersection between the short-run aggregate supply curve and the aggregate demand curve is happening beyond full employment value. The economy is producing 155 in the short run. That 155 corresponds to need, because the ISLM gives you short-run equilibrium. So the economy is in an inflationary gap. You're producing more output in the short run than what normal. So that means if this is your P1, theoretically, when you're in inflationary gap, the idea is that price is eventually going to adjust upwards. See that? That's the reason why we could not, to calculate the long-run interest rate, we could not use the LM, because when price adjusts upwards, remember the short-run aggregate supply curve is going to move upwards eventually. Okay, this price we found was 4. We found this new long-run price. That's what we solved to be 4.008. Okay, that's what is going on here. And then once, so that means eventually the LM curve is going to shift to the left, because when price has to adjust, because the economy has to move back to the long run, the LM curve is going to shift to the what? To the left. This is a function of P2. You're going to be using 4.008 to derive that new LM2 if you want to do that for your interest. And we solved this long run, what? This is now your long run interest rate, which we found to be 10%. So that's exactly, now you can see that the actual numbers in diagram, numerical value, and how you can plot it to see your equilibrium values. So again, this concludes my lecture. Everything that you need to know is in this lecture. As you know, not everything. Chapter 12 on ISLM. Make sure you watch this lecture, sit down and watch it and I've done this. You know, if you're doing that in a group, you might want to watch it in a group and also like, but yourself. This is detailed enough. I'm going to send you the recording again, download it, watch the video. If you want to watch it multiple times, it's up to you. Combine it with chapter 11, chapter 10. The bulk of the exam, remember, is in chapter what? Chapter 10, 11, and 12, where I'm going to have this multiple choice, the problem solving, open-ended questions, 75 points. But the multiple choice questions, the 25 questions I always write on the text, will be drawn throughout the what? Throughout the material we have covered in this class, from chapters 1 through 12. There's some chapters in the middle that we skip. We did not do chapters 8 and 9, growth chapters. You're going to see the chapter 8ings on your canvas, because it's, lecture slides 1, lecture slides 2. So you can easily tell which chapters we have covered in this class. When I say from 1 through 12, there's some in the middle, like about 2 chapters that we have not covered because of it's not relevant for this class. You at this point too, after you watch this video and you understand this material and you work through these problem sets that I give Q&A, make sure you understand everything in these problem sets. Do your homework assignments, redo them, the ones that are relevant to this test. Make sure you understand them. Then you should be able to pass this class with pass the final exam with flying colors. Give it your best shot. Thank you very much. It was a pleasure having you as my students this semester. You all work very hard. And I wish all of you, those ones who are graduating, I wish you success in your graduation. And those who are continuing with Texas State, remember our path may still cross in some of the classes that I teach here at Texas State. Good luck and have a nice break. See you next week on the exam.